Hello student, today we will solve the problem number 2 from Goldstein book of classical mechanics. Problem number 2 in which say that prove that the magnitude r of position vector for the center of mass from arbitrary origin is given by the equation m square r square which is equal to capital M summation of I m I r I square minus half summation of I j m I m j r I j square. Let's start the solution of problem number 2. The problem is show that m square r square is equal to m summation of I m I r I square minus half summation I j m I m j r I j square. We will prove this equation, right? So start the solution. As we know that r the unit vector. What is r? R is equal to the summation of I m I r I divided by m. The vector r defined as a point known as the center of mass of certain system of particle. So what is r? The r vector defined as what we define by r defined as a point known as the center of mass of a certain system of particle. Now, I hope you understand that what is R. So, if we multiply this, first of all, this is equation 1. From equation 1, we write this. If I multiply this R and M, then MR will be equal to summation I m I r I. This is equation 2. Now we will square the equation 1 both side. Squaring equation 2 both side. Then equation 2 become m square and r square which is equal to this square, or we write in separate dimension. This is MIRI and summation of J MJ RJ. Why I take this different dimension? This is because of tensor notation. If I take I is equal to J, then the result will become 0. So because of this, I take the different dimension. It is no matter. It is the same. Now this is equation 3. Or first of all, we multiplying these both. Then m square r square become equal to summation of ij mi mj and rij. Now this is equation 3. As from equation 3, we first find this rij, which is equal to rij. We know that rij is nothing but the difference between I and j. So as we know that Rij is the difference between Ri and Rj. If I square this both sides, then this will become Rij square, and this is become a minus b whole square formula, which is a square plus b square, which is Rj square, minus 2ab, which is 2 Ri Rj. Now we need Ri Rj. So this equation become Ri square plus Rj square, and this is positive. If we take from this side of equal, then this is become minus Rij square and divide by 2, which is 1 over 2 common from these all is equal to Ri and Rj. Now put this Ri Rj, the value of this, which is half Ri square Rj square minus Rij whole square. Put this value instead of Ri Rj in equation third. Now the equation third become m square r square is equal to half summation of ij m I m j, and this is rj square plus 1 over 2 summation of ij mimj and rj square. Sorry, this is ri square. Sorry, yeah. This is ri square. This is rj square. And minus half summation of ij mimj and ri rj square. This and this. Now we will separate the same dimension. Then m square r square become equal to half summation j, and the dimension of mj and summation of jj is outside, and I summation of miri square inside the bracket, plus similar to this half summation of I in mi bracket summation of j mj rj square, and this remaining is repeat is the same. All right, now this equation become m square r square, which is equal to the summation of mj all mass of j, which is equal to capital M. Then this become m divided by 2 and summation of I r I square. Sorry, y'all, I. And similar this, the summation of all masses and coordinate j, I coordinate I will become m divided by 2, and the remaining is summation j mj rj square minus half summation of ij mimj rij square. Now this m divided by 2 and this m divided by 2 are add to each other and in one dimension only I is nothing but j, so we will write m square r square half plus half which is equal to full m summation of I miri square and minus half summation of ij mimj rij whole square, which is the proof of this problem. Thanks for watching my video.